into a difficult question. All right. And it's not really 3.1 that's difficult. It's more sort of 3.2, but you know, we need to do 3.1 in order to do 3.2. Okay, so that's why I wanted us to do this question. All right, so now in 3.1, it asks us to prove that. All right, then they give us the infinity symbol at the top. I hope you can see that. It's sum to infinity. Let me maybe make this a little bit bigger. I think that's better. So prove that the sum to infinity for the rule 4 times 3 to the power of 2 minus k, where k is equal to 1, is a convergent geometric series. Show all your calculations. Well, how do they want us to prove this? How would we do it? Using what information? How do we begin to answer a question like this? What do you think, Matrix?
Can you please repeat the question?
Sure, Noxie. Okay, so I was just asking you, where do you think we should get started? Like, how do you think I should go about, or we should go about proving that a series is convergent and geometric? How would we do that? What are they actually asking us to show? What does it mean? What does the question mean for us? What does a convergent geometric series have that nothing else has that we could use as a definitive characteristic? Anybody know? Okay, so this is what makes these sorts of questions really difficult, because we need to understand what the question is actually asking us. What does it mean? What do they want us to do? So now I don't want to tell you, I want one of you to tell me what's different, or what do you know about a convergent geometric series? What theory do you know about converging geometric series?
Ma'am, I know that converging series is a fraction. Maybe that's it.
Okay. Yeah, it's good. It's going to be a fraction. You're quite right. You're on the right track. Everybody look in the chat. Okay. Tobile's put something in there, and that is exactly it. Okay. Well done, Tobile. You are on fire tonight. Okay. So what makes, yeah, you see the theory coming through here in Jabulo. All right, so we will be able to prove that a series is a converging geometric series if the R value is bigger than -1 but smaller than 100%. So this is the link between understanding the question and the theory that we've learned. Okay, now again, it's asked us to prove it. We have to show that it's true. So in other words, what are we trying to do in Jabulo? We need to work out the value of?
Ma'am, must I
Yes,
answer
go
you?
for it. Yes, please.
Ooh.
We need to solve for?
Ma'am, aren't we supposed to find the sum of infinity?
We don't have to find the sum to infinity. So calculating the sum to infinity is not going to help us answer the question. That's not going to prove that it's a converging geometric series. What will prove that it's a converging geometric series is the value of R. So if we can work out the value of R and we can show that it's bigger than -1 but smaller than 1, then we have proved that it's a converging geometric series. Does that make sense?
Yes, ma'am.
Okay. All right.
Yes,
So,
ma'am.
okay. If it doesn't, then you're more than welcome to say so. I don't mind explaining things again or trying to talk about it in a different way. I really don't mind.
Pardon, ma'am.
Katleho, would you say anything any differently to what I've said?
No, I was acknowledging Tobile actually had the answer in the chat room. So she did understand that you have to first find the only way to prove a convergent geometric series is by working with R. So the only way we can prove it is by proving that R is between -1 and 1, as in it's greater than -1 but less than 1. So I think that's the only way to say it.
Yeah, so I would say here, Katlejo, I don't know if you agree with me, that even though this question says prove that it's a convergent geometric series, what it's not saying is you need to calculate the value of R. So that's what's implied, but is not specifically said. Okay, so that's what's, in English, we use the words implicit and explicit. So if something is implicit, it means that they want you to do it, but they're not telling you directly that you need to do it. All right, but that's what this question wants you to do. It wants you to work out R and then use that to say, yes, this is a converging geometric series because the R value is bigger than -1, but smaller than 1. Okay, so in 3.1, we now know that we've got to work out the value of R. Okay, well, how do we work out what R is?
Ma'am, can I suggest something?
Go for it, Noxie.
Ma'am, I would substitute K into the formula and find my series, and then look at ma'am, and find R from there, basically.
Fabulous, Noxie. I couldn't have said it better. I quite agree with you. So that would be the first term of your series. Okay, let's work out what the second term would be. So we subbed in 1. So that now means we need to sub in 2. So that would be the second term of our series. And we could even work out what the third term of our series is. All right, so this is going to be 2 minus 3. Okay, and then of course, because it's infinite, it goes on forever and ever and ever. So we don't want to do that. Okay, so let's work out what the value of A is, right? The first term of the series. What is the value of A, Matrix?
12.
Beautiful. Okay, it's 12. Good job. Okay, what's the value of the next term? The second term?
Ma'am, do we need
Yes. Sorry, Tabila, was it you asking something?
no, sorry.
It's okay. Was somebody asking a question? Or did you want to say an answer?
Ma'am, I just wanted to give you the answer, but I heard someone speak.
Go for it.
No, I'm
Noxie.
good now, ma'am. Thank you.
Okay. All right. So what's the answer to this term, Noxie?
Isn't it 4?
Perfect. Good. Well done. All right. And then the third term, what's the third term equal to, Matrix?
4/3.
4/3 is lovely. Okay, well done. So that's more than enough information. All right. From this, we are able to deduce that the value of A is 12. Now we want to work out the value of R. Okay, so we can say term 3 divided by term 2, or term 2 divided by term 1. And in this case, the value of R is?
1/3.
And it is 1/3. Excellent. Okay, so there we go. We've got our answer. All right. So this is how we would set it out. We would state that 1/3 is greater than -1, but smaller than 1. Okay. Therefore, this is a converging geometric series. Okay. Perfect. Awesome. Okay, question 3.2. So this is the interesting one. This is the one that I've been wanting us to get to. Okay, let's have a look at this. 3.2 now, Matrix. They say if the sum to infinity of 4 times 3 to the 2 minus k from k equals p is 2/9, determine the value of p. Okay, so they want us to solve for p. So if we have a look at where p is down at the bottom here, okay? K is P. What does that represent? What does the number at the bottom always represent in sigma notation?
The eighth term.
What does the number at the bottom in the sigma notation always represent for us? Let's see who's got. That's fine. Amogelang, welcome. We're glad you're here with us. Right, so the number, so remember matrix. All right, I'm just going to do this on the side quickly and then we'll come back. Okay, if you see sigma notation, so for example, if I have something like this, okay, and I'm just making up a very simple pattern here, and there I do that, and up here I do this. What does this number up at the top 24 represent?
The last term.
The last number subbed in.
The last number subbed in. Clinton, you're onto something. Okay, we'll come back to that now. So this is the last number subbed into the rule. What does the number underneath represent? What is this over here? I'm going to highlight this in a different color. What does this represent? It is the
First number.
first number
Number
to be
subbed.
subbed in. That's it. First number to be subbed. Oh, I'm writing so badly. Okay, to be subbed in. Okay, so if they're asking us to work out the value of P, they are asking us to calculate the value of the first number that is going to be subbed in to the sum to infinity. When the sum to infinity sums up to 2/9. So this bit over here, all right, this equals 2/9. That is the sum to infinity. That is the value of the sum to infinity. So when we are working with the sum to infinity formula, it looks like this. Sum to infinity is A over 1 minus R. They are telling us that the sum to infinity is 2/9. So that means we've got 2/9 is A over 1 minus R. Okay, and that is the first equation that we can make. Is everybody happy with that?
Yes, ma'am.
Go and rearrange it just now, but let's just go back and have a look at the information. All right, so we've used what they've given us. They've told us that the sum to infinity is going to give us 2/9. How are we need a P here, all right? K is equal to P. So what am I going to do with this K equals P down at the bottom? What do you think we should do?
Sub into the formula.
Sub into the formula, absolutely, because that's where we start subbing in, okay? So let's do that, all right? So we've got, let's just write it over here. So we've got, as our first term, we've got 4 times 3 to the 2 minus P. Okay. Then our next term is going to be, what's it going to be?
I think 4 times P to the power 2 minus 2P.
2 minus 2P. Good, well done. And what do you think the next one is going to be?
4 times 3 to the power 2 minus 3.
Oopsie, I'm writing the wrong thing here. Okay, and so whoopsie daisy, where did my, sorry guys, that flew away from me. All right, so now let's have a look what we can do with all of this. All right. So if we now simplify this, we've got 4 times 3 to the 2. I'm going to split this apart, times 3 to the minus p, plus 4 times 3 to the 2 times 3 to the minus 2p, plus 4 times 3 to the 2 times 3 to the minus 3p. Okay, and on the sequence would go. So if I multiply 9, so 3 to the power of 2 is 9, times 4 would leave me with 36 times 3 to the power of negative p. Again, so 36 times 3 to the power of minus 2p, plus 36 times 3 to the power of minus 2p. I'm making a, sorry, not minus 2p, minus 3p, beg your pardon. I am making a sequence out of that. Now, hang on a second. Are we on the right track? Katlego, what do you think?
Hey, just came back. I sent you a message, but it's fine. It's fine.
That's fine. I'm asking you for your opinion. What do you think about what we've done here?
Okay.
Do you think that we could... I'm just thinking, what about if we didn't even worry about expanding all of these over here? Because we know that A in terms of P is going to be this first term, isn't it? Okay, so that's going to be this term over here. That's A in terms of P. What about if we go and sub that into our equation? Because we already know what R is, don't we? And then that would allow us to be able to solve for P. That's what I think we should do. What do you think? A is the first term. So that's 36 times 3 to the minus p, all over 1 minus, and then remember from the first question, r was equal to a
Third. Okay, that makes sense.
That's what I would do here, Matrix. So working out what the rest of these were, it's fine, but doesn't really help us. What we want is that value of a, because we want to be able to go and sub in here and solve for p. All right, so that was how we were going to get p into our equation. Now we're going to need to cross multiply, aren't we? So we're going to have to say 1 minus a third. So we're going to cross multiply, Matrix. You've all gone very quiet. Have I lost you or are you okay? Does this make sense or not?
It makes sense.
You sure? You sure?
Yes.
Yes,
Okay, all
ma'am.
right. So you'll stop me and you'll say, no, I don't understand what you're doing if you don't understand what I'm doing.
Yes, ma'am.
Lovely, thanks. Okay, so we're going to cross multiply, Matrix. So now we want to say 1 minus a third. That gives us 2/3, and 2/3 times 2 is going to leave us with 4/3. So I'm going to put that on the left. Okay, and now we're going to have to multiply 9. Or what we could do here, I suppose, maybe this would be a little bit easier. Oh, no, we can't do that. We've got to say 9 times 36. 36 times 9. Sure, that's a huge number, isn't it? All right, well, let's just see where this goes. 324 times 3 to the minus p. Yes, was somebody going to say something?
Ma'am, is it okay if we still say 324 times 3 to the power of negative p? To the other side, ma'am, the other side. Ma'am,
Well,
you just swap them the way around.
You can do, but that's not going to change. That's not going to change the sign of the exponent, though, Noxie. So it's still going to be 3 to the minus p. Okay, but I think, wait a second. I think there's going to be something interesting that happens here, because what we're going to have to try and do here, Noxie, is we need to try and isolate this base with that exponent. We want that on its own. So if it's being multiplied by 324, we need to divide both sides of our equation by 324. So I think what we should be doing is saying 4/3 divided by 324. And I'm liking what I'm seeing here. I'm getting an answer. I don't know if you guys are getting the same thing. So I'm just going to write 3 to the minus p is equal to 1/243. And I personally am very glad to see that, because I feel as though we're on the right track here. What can I do from this point? What do you guys think we should do?
Ma'am,
Yes.
ma'am, won't we turn the 1/243 into a prime factor?
Absolutely. Absolutely. So the rule here, Noxie, is you've got to equate the bases. Okay, so you've got to equate the bases so that you can equate the exponents. Okay. So either these are your options. Either you can write this as 3 to the minus p equals 3 to the negative, is it 7?
5, ma'am.
5. Thank you. Yes, 5 is 3 to the negative 5. Or your other option, there's nothing wrong with this either, is if you go 1/3 to the p, so now it would have a positive exponent, equals 1/3 to the power of 5. You could do that. Okay, both of those would be acceptable in this situation. Okay, so we need to equate the bases so that we can equate the exponents. You must show that. It is a vital step. You will get marks for it. All right, do you prefer the first one?
Yes,
I suppose.
Yes, ma'am.
Okay, all right. So that means that minus p is minus 5, and of course, p would be equal to 5. Okay. Is everybody happy with that? I'm just going to move it up a little bit so you can see where everything came from. Maybe you're still writing down. Are you happy with that matrix? Is it making sense?
Yes, ma'am.
Yes, ma'am.
Good job. Okay, can we go on to the next one? Are you ready?
Yes, ma'am.
Okay. All right. So now I also want to do another difficult question with you. This came, let me just move our happy little smiley Katlejo over to the side. This came out of, I think this was from, it's either 2017 or 2018. And 3.2 is a lovely problem-solving question, which is why I chose this. And it's difficult. So that's why I wanted us to be able to do this. 3.1 is a little bit easier, but we need 3.1 in order to be able to do 3.2. So let's have a look at this. A convergent geometric series consisting of only positive terms has a first term a constant ratio r, and an nth term tn, such that the sum to infinity, starting with subbing in that n is equal to 3, our nth term is 1/4. So what they're telling us about our sum to infinity in this particular case is what matrix? What are they trying to imply? What does this information tell us? There's a sum to infinity, and the nth term of that sum is going to be 1/4. right? When we start subbing in to our sum to infinity, we're going to start where n is equal to 3, but we don't actually know what the rule is, right? But obviously we don't need it for this particular question in order to do the answers. So now they say to us in 3.1, or I don't know, Katlego, how else would you say that? Can you say it better than me, the pink?
No, it literally says the sum to infinity is equal to a quarter, but we obviously don't know what the rule is. All we know is we're going to start subbing in at 3, end at infinity, and the sum for that specific rule that we don't know, we're not sure of yet, is 1/4.
Yeah.
But there is some additional information in 3.1.
Yes.
And they say T1 and T2 is equal to 2. So I think that helps a little bit.
It does. It does. All right. So when we have a look at question 3.1, they say to us, if term 1 plus term 2 is 2, write down an expression for A in terms of R. So now, those of you that were with us in our previous lesson, we did this in one of our questions, and it's actually exactly this. Well, it's not exactly the same thing, but it's more or less the same thing. So how are we going to write term 1 plus term 2 equals 2 in terms of A and R? How do we do that, Matrix?
It's A plus AR is equal to 2.
Lovely. Okay, so A plus AR equals 2. And Tabila, when they said to you, write down an expression for A in terms of R, do you think that they would be happy if we left it like that? Why is there a second mark?
You need to write the answer in terms of R.
So what do we need to still do here?
I think you should bring the AR to the right hand side.
Okay, but if I move it over to the other side, is that going to help me to write A in terms of R? What does writing A in terms of R mean? When they say to us, you need to write A in terms of R. When they tell us we need to write A in terms of R, what does that actually mean?
I think it means that you should write A in terms. Can explain. I don't know how to explain. But ma'am, I think what I would do here is take out the common factor of A, then I'm left with 1 plus R.
Absolutely.
And then,
okay.
Yes. And then
Absolutely.
I divide 2 by the 1 plus R.
Exactly. Okay. So Jason, I really appreciate your honesty when you said you're not sure. And that's why I'm so glad I asked the question. When they say to you, express A in terms of R, it means make A the subject of the formula. Okay, so make A the subject of formula so that we know what A is in terms of R. And how we do that is exactly as Andile explained. So we need to take out A as the highest common factor. This leaves us with 1 plus R is equal to 2. And then in order to make A the subject of the formula, we need to divide both sides by the bracket. So that means that A is 2 over 1 plus R. Okay, so now Matrix, we're happy. I think we would get our first mark here and we would get our second mark over there. All right, so we know what A is in terms of R. Now they say to us, calculate 3.2, calculate the values of A and R. All right, so now we've got one equation from question 3.1. That is equation number 1. We need a second equation. How are we going to do this? What do you guys think? What are we going to do? Okay, remember they've only given us the nth term of the sum to infinity. So in other words, we've got a series, an infinite series, okay? And when we add, we don't know how many terms we're adding together in the beginning, okay? It could be quite a few, but we know that the nth term of the pattern is going to be a quarter. So we don't know the sum to infinity. So there's no point in us using the sum to infinity formula, okay? A over 1 minus R, because this is also unknown, okay? So that formula, even though it's a question about sum to infinity, that formula is not going to help us, okay? So let's get rid of that. What else is available to us? We're talking about a converging geometric series. And they've told us that Tn is equal to a quarter. Well, could we use that and make an equation? So telling us that the nth term is a quarter is the same as telling us that AR, or let's see what someone said.
Oh, so ma'am, that's 1 over 4, but there isn't actually the sum of infinity.
It is, sorry. You're quite right. I've just had a look now. Okay. Yes, the sum to infinity is 1 over 4. Sorry, I misunderstood that. We don't know what the rule is. Yes, but the sum to infinity is 1 over 4, 100%.
Oh,
Sorry,
now,
I'm talking I'm talking nonsense.
Equation.
Okay, so sum to infinity is A over 1 minus R, and that 1 over 4 is our sum to infinity. Quite right. Okay, so let's put the 1 over 4 there is equal to A over 1 minus R. Okay, lovely. Well, that does make a lot. Okay. Hang on a second. I just want to answer something in the chat. Njabulo.
Yes, ma'am.
Okay, so I'm not picking on you here, but I feel so bad for you that you say that you're confused. Where did I lose you in Jabulo?
Before you fix this, ma'am, I
Oh, so did you really not understand anything that we were saying?
Yes.
Okay, all right. So in other words, what we've got is this. Okay, we've got a sum to infinity. We start subbing into this rule that we don't know when n is equal to 3, and it's a sum to infinity. That's why the infinity symbol is at the top. We don't know what the rule is that we're subbing into, okay? And we don't need to know what the rule is, right? Because we don't need that to answer the question. So this is unknown to us. But by them writing that this sum of this term, this nth term that we don't know what it is 1 over 4, they are telling us that the sum to infinity is 1 over 4. Okay, that's what they're trying to imply. All right, so the sum to infinity is 1 over 4 of this unknown rule that we are working with. Okay, but we don't need to know the rule to work out A and R. Right, so they're telling us the sum to infinity is 1 over 4. Okay, now let's go back and go and sub that in. All right, we've done that, 1 over 4. Now, remember, we can only work in terms of one letter. We can't work in terms of 2 letters. So we know what A is equal to. So what we can do is we can take out our A and we can replace it with what A is equal to in terms of R. So in other words, our next step over here is to write a quarter. 1 over 4 is equal to A is 2 over 1 plus R, and that's all being divided by 1 minus R. Okay, so now we've got a proportion statement again, where we're going to have to cross multiply to get rid of the denominator. Okay, so what we've got to do is this. Okay, very, very careful. We need to multiply the denominator over here by that numerator. And then we need to multiply the denominator on the left-hand side. Let's put that in a different color, by this numerator over here. All right, so when we do our multiplication in blue, 1 times 1 minus r, we're going to get 1 minus r. On this side over here, we're going to end up with 4 times 2 is 8, and it's going to be 8 over 1 plus r. Now we have to get rid of the denominator. How are we going to do that? What do you think?
And we're going to times the denominator on the right with the answer on the left.
Absolutely. Okay, so we're going to multiply the denominator on the right with what's left on the left. Okay, because this 1 minus r means 1 minus r over 1. So we're going to multiply the two blue ones together. Okay, so let's do that and let's see what we end up with. Okay, so we've got 1 minus r times 1 plus r, and that's going to be equal to 1 times 8, which is 8. Now, if we multiply these brackets out, all right, we're going to end up with an interesting solution because this is difference of two squares. So doing FOIL, I would end up with 1 times 1 is 1, okay, plus 1r minus 1r minus r squared is going to be equal to 8. Okay, so the plus 1 minus 1 r is going to go away. Right now, what I want to do is I want to have my r squared on one side and my number on the other side. All right, so what if I do this? Let me take this over to this side, and that's going to give me r squared. But hang on, now something's wrong here, Katlego.
Yeah, I'm seeing it now as well. Because we're going to have a negative that we'll have to square root.
You can't square root a negative. Something's wrong. What have we done wrong? You see, I thought myself, have I interpreted that incorrectly? Hang on a second. 8 minus 1 is 1 over 4. No, but then you've got n. Oh, but hang on, if you put in 3, AR to the 3 minus 1 is 1 over 4. 1 squared, 1 over 4. A was equal to 2 over 1 plus r times r squared is equal to 1 over 4. Okay, so that gives us, I don't know if this is correct, 2r squared over 1 plus r equals 1 over 4, which leaves us with 8r squared is equal to 1 plus r, yeah. So that gives us 8r squared minus r minus 1 equals 0. So 4r, 2r, that's obviously got to be 1 and 1. Will that factorize?
No, that won't give us negative.
That's not gonna give us the minus r in the middle. Let me just quickly check on my calculator. Let's see, wrong one. Okay, so we've got 8 minus 1. No.
Ma'am, can I ask something?
Yes, of course. I'm just trying to figure out what we've done wrong here. Yes, go for it.
Ma'am, like the 4 that you highlighted in green.
Yes.
You times it by the 2 above, not the whole thing, not the whole term.
Because you see, when you multiply fractions, you multiply numerator with numerator and denominator with denominator. So so that 4 is being multiplied with the 2. That's why we would have ended up with 8. at the top. Okay, 8 over 1 plus r is equal to 1 minus r. Okay. All right. Katlego, let's find our mistake here. What have we done wrong?
Please scroll up to the question. I just want to see
Sure.
the information.
Can you put us chairs in Mama's room?
Here we go.
The red one. In Mama's room.
Ma'am?
Don't we need to add 2?
Excuse me, ma'am.
Because we don't know how many terms there are in this particular pattern. And we know that the sum to 2, I think we need to add, this is what I think we need to do. I think we need to add 2 here.
Okay.
Let's just try that. Because I don't think this is telling us that the sum to infinity is a quarter. I think that this is telling us that the nth term of the sum to infinity pattern is a quarter. That's how I interpreted this question. So in other words, here, the nth term of the pattern is a quarter. So that's why if the nth term of the pattern is a quarter and the sum of the first 2 terms is 2, then it would make sense that the sum of the series would be 2 plus the last term, the nth term, which would be 2 1/4. Don't you think? Let's just see. Let's try.
You mean?
Just
Yeah,
to see what I
you
mean.
Yeah.
Okay, so if we say 2 plus a quarter, that's going to leave us with 9 over 4. That's going to leave us with 9 over 4. Let's just try this and see if this works. But I think this is what we're supposed to be doing. Okay, so we're going to multiply that with the 2. And we're going to multiply the 1 plus 1 minus r with the 9. Okay, so let's just clear this. Okay, so that is going to leave us with 9 times 1 minus r is equal to 8 over 1 plus r. So we've now got 9 minus 9r, cross multiplying again with 1 plus r equals 8. That gives us 9 plus 9r minus 9r minus 9r squared is equal to 8. Okay, and now that plus 9r minus 9r is going to add up to 0. And we've got minus 9r squared is equal to 8 minus 9. So that means that minus 9r squared will be equal to -1. So if we divide by 9 on both sides, that means that r squared is going to be equal to 1 over 9. So therefore, r is going to be equal to 1/3, or r is going to be equal to a -1/3. What did they say about r? Okay, they didn't tell us. They didn't say that r had a restriction on it. So I think r can be 1/3 or r can be a -1/3, which means that there would be 2 different values for a as well. All right, so in other words, we would now need to sub back in to equation number 1 and then work out the 2 different values for a. Yeah, look there, calculate the values. Yes.
Ma'am, can you please start again because like my network was giving me problems.
And I'm so
fine.
confused, man.
That's fine. I'm sorry you guys are confused. Let's talk about this again. All right. I think the problem here is the way in which we first interpreted what this means. They are telling us that the nth term of this particular series, the last term of the pattern, is 1/4. That's the nth term of the pattern. That's the last. So in other words, the series is created by adding certain terms together, and the very last term in the pattern is 1/4. I don't think that they're intending for this 1/4 to be the sum to infinity. That is the nth term of the pattern. All right. And here, where they tell us we start subbing in at 3, I don't think we actually need to use that right now. They've told us, yeah.
Okay, now that we're looking at this, I actually got a different interpretation using exactly what they gave us.
Okay.
Okay. So they said to us, the sum to infinity from n equals 3 is 1/4. Okay. But this time we're using a series as in Tn. So we know that there is a T1 and a T2. So the trick was the sum from T3 is 1/4. But we have to remember and know to add the 2 they gave us in 3.1 because there is a term 1 and a term 2. There has to be an A and a term 2.
Yes, that's right. That's what it means. Thank you. Say that again. That's perfect.
Okay, everyone. So what they said is the sum of a series from term 3 to infinity is 1/4.
That's it. The
Okay.
sum of
But we know that there is a term 1 and term 2. There has to be a term 1 and term 2. So we have to get our additional information from 3.1 where they said term 1 plus term 2 is 2. So the sum of the entire series from term 1 has to be the 1/4 plus the 2 from 3.1. Do you guys understand now?
Oh, yes, thank you.
Katlego, you are wonderful. Absolutely. That's what I couldn't articulate. I'm so glad that you're here and you can help me. But that's exactly it. So I think you've put it beautifully. So the sum of a series from term 3 is 1/4. Absolutely. So now we have to add term 1 and term 2 to that to get the entire sum to infinity. And then that's why our solution, what we've done here, is correct. Absolutely. Does that make more sense now, guys?
Yes, ma'am.
Okay. All right, lovely. Okay, so last thing that we would need to do is work out the values of A. All right, so A was equal to, what was it equal to? 2/1 plus R. Okay, so let's work that out. Okay, so A is equal to 3/2. Okay, so this is a converging geometric series. Okay, so if it's a converging geometric series, then those solutions for R will be acceptable. Okay, so if r is equal to a third, a will be 3/2. If r is equal to a negative third, then a would be 3. Okay, does that make more sense to you, Matrix?
Ma'am, please repeat the whole thing.
Okay, Noxie, let's go through it again. That's fine. Okay, so it all comes down to the way in which we have interpreted the information that's been given to us. Right, so in this particular question, it all comes down to us understanding what this that I'm highlighting, what it means. All right, what does that mean? Okay, so they are telling us that there is a sum to infinity, all right? And that because we're starting to sub in where n is equal to 3, all right, what they mean by this bit on the right here is that the sum of the series from the third term is going to be a quarter. So the sum of the series from the third term onwards to infinity is a quarter. So in other words, we have term 1, we have term 2, and then we have a quarter. And this will give us our sum to infinity. That's what they're basically saying to us. Does that make sense?
Yes, ma'am.
Okay, so the sum to infinity from the third term onwards is a quarter. That means that term 1 plus term 2 plus that quarter is going to give us our sum to infinity. All right, we now know from the first question that we did, we know what the sum of the first two terms is. We know that it's 2. So we've now got 2 plus a quarter, which is our sum to infinity. Okay, so that means our total sum to infinity is not a quarter, but rather 9/4. Okay, not 1/4, but rather 9/4. So the mistake that we made in the beginning was we forgot to add in that 2 over there. All right. And then what we've done after this, let's just get rid of that. We need to have time for the quiz as well, is we've said, all right, we need to sub in sum to infinity. So we know that sum to infinity is a over 1 minus r. Our sum to infinity is 9/4. So in other words, 2 plus a quarter. And we have now replaced a with what a is equal to in terms of r. All right. So in other words, this over here. So in place of a, I'm writing 2 over 1 plus r, and then I've got my divide line over here, so my divide line over there, and I'm going to put 1 minus r in the denominator, and then I'm going to cross multiply. Okay, so I'm going to multiply this denominator over here with this numerator, and then I'm going to multiply this denominator over here with that numerator over there. Okay, so that's going to leave me with 9 times 1 minus r is equal to 8. 4 times 2 is 8, still over 1 plus r. So now expanding my brackets, 9 times 1 is 9, minus 9r, put that in brackets, and now I'm going to cross multiply again, is equal to 8. Okay, so now when I remove my brackets, I end up with 9 plus 9r minus 9r minus 9r squared, and that's going to be equal to 8. Okay, those are going to add up to 0, and if I take my 9 over to the other side, minus 9r squared is going to be equal to -1, which means that r to the power of 2 is 1/9. And that's why we went back to the beginning where we said, well, either r is going to be a positive third or r is going to be a negative third. Does that make more sense, Noxie?
Yes, thank you, ma'am.
All right, no problem. And then you would just go and sub back into what you derived in A. Okay, well, derived in 3.1 for A, which is this over here. And then you need to go and sub those R values back in there. Okay. And that's how you would do that question. Well done, Matrix. And thank you, Katlego, for all your help and for putting things into words so nicely for us. Okay, so Matrix, we need to say goodbye now, unfortunately, and you guys are going to run off and go and do that quiz. And then we will see you again next week on Tuesday, and we'll be doing the course in geometry. Okay. Well done, everyone.